Okay, everybody, today we will be finding some angle measures. So this is going to finish up chapter 1 for us here. We're just going to take some of the angle relationships and maybe the angle addition postulate that we've done the last few days, and we will use that to find some numbers. We will do a little bit of algebra, and we'll have some fun, hopefully. So let's jump right in. All right, so we're going to use angle relationships here to find these angle measures. There's 20 on here. I'm not going to do all 20 in this video because that would take a long time and we don't necessarily want to spend that much time on this. But if there's any that you see that I didn't do, send me a message. I'll put these up here too on Classroom. But let's start at number 1. So we've got this 112-degree angle, and then we've got this angle with x degrees, and we want to find what x is. So on all of these, the first thing that we want to do is ask ourselves, what is the important relationship? So we do have a couple of vertical angles here, and we know that vertical angles are congruent. So that must mean that x is 112 degrees. So once you find the relationship, then these are usually pretty easy. It's just kind of like solving a puzzle. Let's move on to number 2. So what looks important in this diagram? All right, we've got this right angle right here, which means that we have a couple of complementary angles by the angle addition postulate. So we know that 90 minus 68 degrees is going to be equal to whatever our x is. So 90 minus 68 is going to be 22. So our x is 22 degrees. Moving on to number 3, let's figure out what important relationship we have here. Okay, so this is a linear pair. These are both adjacent and supplementary. So that means that if we add up 124 plus x, it's going to be equal to 180 degrees. So we take 180 minus 124 to find x, which gives us an x of 56 degrees. All right, moving on to number 4. We've got a few different ways to solve this. On some of these, you don't ever have to go in order, and sometimes you won't want to go in order. On this one, we can kind of go in whatever order we want, so I'll just do x and then y and then z. All right, so to find x, what is the important relationship here with this 43 degrees? All right, we have a linear pair again. So x and 43 together make up a linear pair. So that means that 180 minus 43 will get us our x. So that means that our x is going to be equal to 137 degrees. And that's really all we need to know to find y and z. So if we want to compare y to x, we could do that. But if we want to compare y to this 43-degree angle, then what do we have? All right, we've got another pair of vertical angles. So since vertical angles are always congruent, then that means that y is 43 degrees. And then finally, we've got 2 different ways to find z. So what is the measure of angle z? Okay, it's going to be 137 degrees. We can see that by the linear pairs we have. We have a linear pair right here. We've got a linear pair if we go diagonally, or we have vertical angles. Angle x and angle z are vertical, so they are congruent. So a couple different ways to find that. Okay, moving on to number 5 here. We've got, again, x, y, and z, and we could solve these in whatever order we want. But let's just start with x again. If we look at this 72-degree angle and this x, what is the important relationship? Okay, these are a linear pair again, so they are supplementary. So if we say that 180 minus 72 is going to be x, then x is going to be equal to 108 degrees. Okay, we can do the same thing again with y. We can, just like in number 4, we've got y is vertical to our given angle, or it makes a linear pair with the one that we just found. So either way we do that, we are going to get 72 degrees. Z is a little bit trickier. What is the important relationship between Z and this 72-degree angle? Okay, hopefully you notice this right angle over here on the bottom left, and that means that this entire bottom right box is going to be 90 degrees. So 72 and Z are complementary angles, which means that they add up to 90 degrees. So if we've got a 72 degree angle, then to get to 90 degrees, we need an 18 degree angle. So Z is equal to 18 degrees. All right, so those are the diagrams there. Let's do like one of these word problems here. They all turn out about the same. 6 is a little bit easy, so let's move to number 7. Okay, so A and B are complementary angles. This is where knowing your vocabulary really comes in handy. The measure of A is 42. We want to find the measure of B. So, since A and B are complementary angles, what do they have to add up to? They'll add up to 90 degrees. So let's see, we can say that angle A plus angle B is equal to 90 degrees. And since we have angle A, we can say that 42 degrees plus angle B, I guess that would be technically the measure of angle B. And up here, if I want to be more accurate, which we should always strive to be accurate, that would be the measure of angle A plus the measure of angle B. But either way, it is 90 degrees still. And that means to find angle B, we just need to subtract 90 minus 42. So the measure of angle B is going to be equal to 48 degrees. And that's how we would find that. So anytime you've got a word problem like this, know your vocabulary. Know that vertical angles are congruent. Know that complementary angles are 90 degrees when you add them up. Supplementary are 180 degrees, and a linear pair also comes to 180 degrees. Know that. All right, let's do a couple of these. We've got some diagrams again. This time we got a little bit of algebra, and that's fine. We can do algebra. So right here, we've got the measure of angle PQT is 3x plus 47. So I'm just going to throw that right on the graph. 3x plus 47. So that's PQT. And SQR is 6x minus 25. And what kind of relationship do these two angles have? All right, these are vertical angles, so that means that they are congruent and their measures are equal, which means that we get to use one of our favorite tools, which is the equal sign. So 3x plus 47 is equal to 6x minus 25. From here, we can just solve a little bit of algebra. So if we subtract 3x from both sides, we get 47 equals 3x minus 25. We want to keep isolating that x, so let's add 25 to both sides. That's going to get us 72 equals 3x. And then finally, we divide both sides by 3 to get x equals 24. But we always need to ask ourselves, are we done? This is asking for the measure of SQR. So to find that measure, we need to substitute 24 back into this expression. So the measure of angle SQR is equal to 6 times 24 minus 25. And you can just do that in your head or punch it in your calculator. So the measure of angle SQR is equal to, let's see, 6 times 24, that is going to be 144. And if we take 144 minus 25, I believe, if I'm doing this correctly, that is 119 degrees. And now we can double check ourselves by substituting in for PQT because we know that those are congruent. So 3 times 24, that's going to be 72. And if we add 72 plus 47, that is also 119. So we've done it. We've figured it out. All right. On number 11 here, we've got AB is perpendicular to CD. What does that mean about this angle ACD right here? Okay, and we're also given that angle DCE is 7x plus 2. So I'll put that in there. And we're given that angle ECB is x plus 8. So I'll put that right here. Now, what kind of equation can we use to solve for x here? All right, the right angle here, because of the perpendicular line, so we've got a right angle, and if this is a right angle, then this is also a right angle. So that means that these two expressions add up to 90 degrees. So we can say that 7x plus 2 plus x plus 8 is equal to 90. And from there we can solve. So let's combine some terms. We have 7x and 1x, so that means we have 8 x's. We have 2 plus 8 is 10, and we did not do anything to the right side of that equation. So we've got, we want to subtract 10 from both sides. 8x is going to be equal to 80 after we do that. And then finally we want to divide both sides of that equation by 8 to get x equal to 10. And again, we need to look at what the question is actually asking. It's asking us to find the measure of DCE. So the measure of angle DCE is equal to 7 times 10 plus 2. And this means 72. So the measure of DCE is equal to 72 degrees. All right, let's do one more. Let's go down here. 13 is a good one, but I'll leave that one for you. I want to go down here to number 19. We've got a little bit of a complicated diagram. So let's see what we can figure out. We've got ray MO is bisecting angle PMN. And we've got angle PMN is 74 degrees. And angle OMN is 2x plus 7 degrees. And we want to find the value of x. So if MO is bisecting angle PMN, then that means that both of these smaller angles are congruent. So we've got two small congruent angles here. And we've got angle PMN is going to be 74 degrees. And then we've got angle OMN, which I don't have much room in there, so I'm not going to type it in there, is 2x plus 7. So what kind of equation could we use here to solve for x? Okay, there's a couple different ways that we can do this depending on if you want to multiply by 2 or if you want to divide by 2. But the important thing to know is that PMN is exactly twice as large as OMN. Because this is bisected, it's cut in half. So that means that if we divide this 74 in half, we will have OMN. So we can say that 2x plus 7 is equal to half of 74. So 1/2 times 74. Because this OMN is half of PMN. And then from there we can say that 2x plus 7 is equal to 37. We can subtract 7 from both sides to get 2x is equal to 30. And then finally we can get an x of 15. And it says to find the value of x. So we did. We've got x equals 15. All right, bring your questions tomorrow, and I'll see you then.